So here we have a planet called Kokomo, and it has a radius of 4.1 times 10 to the fourth power meters, and we have a mass of 4.8 times 10 to the 21st kilograms. We have our constant g listed. We have our r vector from the center of Kokomo to the center of the asteroid, and that is 1.2 times 10 to the 8th meters. We have our asteroid's radius. It's 3.7 times 10 to the second. And we have the mass of our asteroid, that is 7.2 times 10 to the 6 kilograms. So below I give a code for what Kokomo looks like, where it is, and I give its radius to be equal to the constant I have given above. I said to attach the trail, so whenever I do run the program, I can see where it moves and how it changes. I have the asteroid, and it offers the same information, and I have the trail, so I can see the same information as Kokomo once I run the program. I have Kokomo's mass equal to the constant given above, as well as the momentum below is given by the constant of the mass times the vector's initial velocity, which is 0, 0, 0 in this case. And the asteroid, I have the likewise information below. But in this case, I have given it a initial velocity of 5.2 times 10 to the third power in the x direction, meters per second. Next, I gave the vector r of Kokomo and the asteroid listed, and I listed them so I could go ahead and find the r hat and show that r hat is equal to the vector r distance from the center of asteroid to the center of Kokomo, and I divide it by the magnitude of that squared to find r hat. I gave my time to be initially at 0 seconds. I wanted to start doing my calculations and have a 0.01 second change of time interval for my calculations. I gave a loop that is supposed to last for 1800 seconds. Once it reaches that point, it's gonna cut off and stop giving me information on the equation. I have it giving me a rate at 1000. Not sure exactly what that means, but it's at 1000, which is going to happen fast and do lots of calculations for me. I have gravity, the net force of gravity given by the constant g, which is given above, and I go ahead and multiply everything out. It's going to be dividing everything by the magnitude of r squared, and then multiply the top by the mass of Kokomo and the mass of the mass of my asteroid, which is going to be RA. MA, we got that. So we got MA and MK. And then we multiply this by the r hat, the unit vector, to give the direction of the force. I want these to be calculated for each time step because it's going to change as the distance r from the center of the two objects changes. The gravity force is going to get stronger as this distance becomes smaller, and the momentum and the position of my asteroid as well as the planet will be changing over a period of time. So I have the time given by the initial time of 0 plus my change in time, which is 0.01, and it doesn't run. Bummer. Gotta work on it. Alrighty, appreciate it.